provisions. What we are going to be doing today is taking a look at Chapter 12 of the TMS 402. I'm looking at the 2016 version. I'm going to be using that primarily. The 2011 and 2013 version of those codes may be in effect in your jurisdictions still. There's not a lot of difference in there. I'll try and explain where there are some differences and where there are not. So a lot of this is applicable to your current design practices, and as you change over to the 2018 version of the IBC, you will then be engaging this particular version of the Masonry Standard. We're going to be looking at rational design of veneer systems, which are currently allowed under this Chapter 12, and we're also going to be looking at the design of the vertical supports of that veneer system to look at how you actually should do it based on a lot of studies we've done over the past few years. All right, the learning objectives in here specifically are to look at these alternative design procedures for masonry veneers. We are going to go in here and look at the alternative procedures as I indicated in Chapter 12. We're going to present an example of a rational veneer design. I'm just going to do one there. One of the reasons for that is the prescriptive provisions in the 2016 version has reduced the need because we have a wider cavity allowed for the prescriptive provisions than we used to have, so the demand isn't as high as it used to be, and I'm just going to give you an overview of how to apply the provisions to an example. However, I'm going to be looking at shelf angle design. We'll do two examples in that particular area. So hopefully we can cover a wide range of the design decisions that you have to make when you're actually designing these elements. All right, first of all, I'm assuming everybody has access to the TMS 402. This is the TMS 402, used to be referred to as the ACI 530 and ASCE 5. The 2016 version of that code is under all of those, 2011 version is under all of those designations. The 2016 version actually cuts out all of these numbers, and there's no longer an ACI 530 or ASCE 5 designation in effect. In that Chapter 12, they describe the design of anchored veneer. It shall meet the requirements of Section 12.616, or it may be designed rationally by 12.2.1 or prescriptive requirements in 12.2.2. So you have to meet the basic provisions in there that relate to detailing and waterproofing, etc., and handling water in the wall system. And then you can either prescriptively design it or rationally design it. The vast majority of all anchored veneer systems in the U.S. are designed prescriptively, and most of the rational designs have been done on very unique structures or in a retrofit application trying to fix veneer systems that are not performing adequately or were badly constructed. Okay, we also have an issue in high wind zones and high seismic zones, or in unusual configurations when you get very large cavities. You cannot use the prescriptive provisions even with the increases that we currently have. We have people that are trying to stuff 8 inches of insulation in that cavity, and you cannot prescriptively design that wall system if you have that much insulation in between the brick and the backing wall. In addition, these prescriptive provisions, particularly when I'm coming in and trying to retrofit, are not very effective. To do that, to replace them back to the code-mandated configuration gets very costly. So when you're rehabbing veneers, you generally want to do a rational design because it's much more cost-effective. So let's go in and take a look at these provisions that are in the code. What we're looking at in here is we have an exterior clay brick veneer in here, typically clay, but you can also have concrete brick here or calcium silicate elements that go on the exterior face of the exterior wall system. Then you typically have a cavity, a drainage cavity in between the backing wall, and that drainage cavity may or may not have insulation in it, but you need a free draining 1-inch minimum between there, and then the water goes down the backing, drops down to the bottom, is collected on flashing, and delivered to the exterior of the veneer. The backing walls, you can have wood or steel stud backing walls in here. Typically they're 16 inches on center, either steel cold form sections